we're solving problem 11 from the 2018 F equals MA exam B. A circle of rope is spinning in outer space with an angular velocity omega sub 0. Transverse waves on the rope have speed velocity 0 as measured in a rotating reference frame where the rope is at rest. If the angular velocity of the rope is doubled, the new speed of transverse waves as measured in a rotating reference frame where the rope is at rest will be blank, and then we need to fill in that blank. So we can start to solve this problem because we know that in this frame we are given this equation right here, this fancy equation, 2t sine of d theta over 2 is equal to f sub c, which is dm omega squared times r. Now, this can simplify by just getting rid of the sine. So then we have 2t times d theta over 2 is equal to dm omega squared r, where the 2's cancel, and t is equal to d over d theta omega squared r. Now remember, we have to incorporate this speed of waves in a string, and this is where it comes in. Also, this is equal to m omega squared r over 2 pi. This is where speed of waves in a string comes in. So we have velocity is equal to square root t over m over L. So this is essentially t times L over m. So we can reiterate it in this case. So we have velocity, if it's doubled, we have the square root m omega squared r over 2 pi times 2 pi r over m square rooted. And all of this, we just get omega times r. And what this correlates to is basically, this says that if it's doubled, this is basically, since it's proportional to each other, it's also going to be doubled. So we have 2v0 as our answer for this problem.